Hey everyone, welcome to this session in IBDP MAI course. Today we are going to talk about the SL4.3, and in this topic we have the following concepts like measure of central tendencies, what is mean, what is median and what is mode and how to calculate these. And what is the model class and how to find that model class, then interquartile range, standard deviation and variance. Then we will see what is the effect of constant change on the original data and quartiles of discrete data also. So basically in this session, I will tell you how to find these values manually, right? Later we will discuss in the other sessions how to find all these things using our GDC as well. Okay. Today I'll use the definitions only. Okay. So I'll take help of the calculator for calculation part only, not for entering data and getting the direct results. Okay. So the following things are given to us. It says for the following five data points, find the median value and mean value. What is median? If you arrange the data in ascending or descending order, then the mid value is called median. If you have if you have to find the mean, what is mean? Mean is average value, right? If a data is given to you, you can find the average of that whole data. Next is mode. What is mode? Mode is that data point which is repeating most of the time. You may have more than one modes also. Okay, like there are three numbers which are repeating five times, and five times is the maximum number of times in that data set. So yes, you can have more than one mod in that case also. Okay, so let's start with this one. Let's first arrange this data set in the ascending or descending order. Then the middle value will be our median value. And for the mean, we can add up all the data divided by total number of terms to get the mean, right? And this is for the discrete data set. Okay, discrete data. Now the solution. So when I arranged all these values, I found this is the arrangement in the ascending order. Here we have the five terms. So if you have five terms or the odd number of terms, then middle value will be the median. In this case, the third one is the median. If you have even number of terms, in that case, the average of middle two terms will give you the median. For example, here we say have 22.5 also. Let's say total six observations are there. So in that case, the average of these two means you have to add them up and divide it by 2. That will be your corresponding median. Okay. But in this case, in this particular question, we have only 5 data points. So remove it. Now, mean value. For mean, you have to add up all the data points, add them up and divide by total number of terms, which are 5. That gives us 20.59. Okay. Now, write down the mean, median, and mode of the following data sets. So, as I said, you have to arrange the data in the ascending or descending order to find the median. Mean you can find directly. Okay. So, for the median part, let's arrange this data 14, 14. Then we have 16, 17, 19, 20, 23, and 25, right? Which is already in the ascending order. Now, here, what we can do, we can find total number of terms. So, in total, we have 8 terms. So, the median will be given by average of two middle terms. So, take 17 for the median, 17 plus 19 divided by 2 comes out as 18 is the median value. Now, for the mean, mean is given by sum of all observations divided by total number of observations. So all you have to do is you have to add up all the numbers 14 plus 14 plus 16 plus 17 plus 19 plus 20 plus 23 plus 25 whole divided by total number of terms 8. That gives us 18.5 as the mean or the average value. Now the mod. Which term is repeating most of the time? Yes, 14 is the point. So mod will be given by, that's the mean. We also represent mean by mu, okay, or x bar. So mod in this case comes out as 14, which is the most occurring value. Now, next question says the number 4, 8, 2, 9 and x have the mean 7. It means sum of all these observations divided by total 5 observations are there. This value is given as 7. You have to find the value of x from here. So 4 plus 8 plus 2 plus 9 plus x. Sum of all 5 observations divided by 5 gives me 7, and hence we can simply solve this for the value of x to get our answer. Okay, so in this case when you simplify it, it gives me 35 minus these values 4 minus 8 minus 2 minus 9, that finally comes out as let me solve this one. So 35 minus 4 minus 8 minus 2 minus 9 gives 12, is that value of x. Okay, next one. Next problem says, okay, if you have to estimate the mean of the following data. Okay, for finding the mean, what do you need to do? For finding the mean, you have to take the sum of all data points, but this time you have an interval, you don't have x value. So for x value you have to convert it, you have to find the mid values of the intervals to get your value of x. So take the mid value of this interval, that will be your x value or marks. Then we can multiply that with the frequency, right? So here what are the mid values? 15, 25, here it is 40, and here it is 55. Now in order to get the mean, later we will discuss, we can easily solve these questions with the GDC as well, but here we are using the definition only. So now if we have to find the mean, so mean is given by summation of fi frequencies product with xi values divided by sum of all frequencies. So here what we have, mu is given by 10 times 15 plus 12 times 25 plus 15 times 40 plus 13 times 55 whole divided by total number of sum frequencies comes out as 50. Okay, now when you simplify this, this value comes out as mu is equal to 35.3. That's the answer. Now next part says, explain why it is only an estimation, it is not correct value. Why? Because we are taking intervals, we are not sure that the x values are only 15, 25, 40 or 55. No, we are just taking the averages only, right? We are taking only the mid values to get the x values. We don't have marks, we have intervals. So that's the only reason this is just an estimation, it is not an exact value. Okay, like the previous one in the 14th question, here we solved for exact value. Okay, 18.5 in that case was exact value of the mean. Now there are three things about you can say relations that you can make between the mean, median and mode corresponding to symmetric distribution. If the data is distributed symmetrically, like here as you can see, mean, median, mode will be same almost, right? If the data is symmetric. But if the data is positively skewed, right? Here it is positively skewed. So in that case, there will be mode, then median, then mean. So you can make this inequality like this. But if the data is negatively skewed, like this is the negative skewed, third part. Here it is negatively skewed, so mean is less, right? Median is less than mode. This one. So this you can find out between the you can say relationship between the mean, median and mode for the given data set. Now standard deviation, it's very important. Mean, median, mode were central tendencies, right? Here we have the standard deviation. It is the measure of dispersion that gives us, it's a measure of dispersion, standard deviation. Basically, the standard deviation tells us how closely the values of data sets are clustered around the mean. If the standard deviation is a very large value, in that case, there is a high difference, right? Very big difference between the data set points. If the standard deviation is very small, it means the data sets which are given to us are very close to each other. Okay, there are formulas for mean, median and mode. Similarly, we also have the variance and standard deviation. Basically, variance is only the square of the standard deviation. If you get using the calculator also, you will get the standard deviation. You can directly take the square of that to get the variance. Okay, so the variance is given by summation of xi means observation minus the mean value whole square divided by total number of terms. So what you can do, you can take all the observations xi, subtract mean from them, take the sum of square of those values, whole divided by total number of terms or the frequency sum. That gives you the variance then represented by sigma square. If you take the square root of this, you will get the standard deviation. Okay, it tells us the deviations, right, about the mean value. Here is the question. Find the model class. Model class means mod will lie in that interval. So for that part, you can just make an estimation. Okay, again, it is just an estimation. You can see maximum frequency is 18. So maximum frequency is 18 means too many values are lying between 15 to 20. So it is just an approximation that because highest frequency is there, frequency is highest here, the corresponding class, this class will be the model class, okay, which is 15 to 20. Now, for the data set given below, you have to find the interquartile range, standard deviation, and the variance. You can simply use your calculator as I said, but okay, let's do these with the help of formulas. So for the first part, interquartile range. For that part, we need to make the quartiles first. So given data is already in the ascending order. So you remember 6, 7, 9, 12, 14, 18, and 22. Quartiles will divide this data set into four parts. So if we take the mid value, how many terms are there by the way? There are in total 7 terms. So the middle value will be this number. This number is going to be our quartile 2 or the median value. Then take the median of all the values left to median. So this one 7 in this case will be the lower quartile. Similarly, take the median of values right to the median value, right, of the data set, means in this case 18. So that is your quartile 3. Now we divided our data set into four parts, 6, then we have 7, then we have 9, then we have 12, then we have 14, 18, and 22. And out of those, 7, 12, and 18 are Q1, Q2, Q3 values. Okay. Now, interquartile range is given by Q3 minus Q1. So, Q3 minus Q1 gives me 18 minus 7, which is 11 in this case. Now, the next part, the standard deviation is given by summation of xi minus mu whole square divided by total number of terms, right? So in this case, how many terms are there by the way? 7 terms are there. You have to take the square root also. So mean you need to calculate first. So the data values are given to us, right? So we can find the mean of this data set. Here, the mean, let me write the mean value of this data set, which is coming out as 6 plus 7 plus 9 plus 12 plus 14 plus 18 plus 22. Total 7 terms are there. So I got 12.57 something. 12.57. Now I have to subtract 12.57 from each of this. Okay. And that gives me the standard deviation divided by 7. So all I have to do is this 6 minus 12.57 whole squared plus 7 minus 12.57 whole squared and so on up till the last value, which is 22 minus 12.57 whole squared inside the square root. Okay, once you solve this you can easily get the value. Okay, so here after simplifying this I have the value. I will get standard deviation is 5.44. Okay, so we got sigma as 5.44. Now it says find the variance also. We know the variance is given by sigma square. So you just have to take the square of this 5.44 whole squared gives 29.593, which is around 29.6, you can say. Next problem says a data a set of data has mean 12 and standard deviation 10. Every item in the data set is doubled, then 4 is added, then what is the mean and what is the standard deviation? Means how the addition or multiplication by a constant number affects the data set. So for that, you can write this thing. I'll tell you. If the changes are like this. Originally, data was in x. Later, we wrote it ax plus b. Okay. Instead of x, if we multiply it with a and added a b number to it. So, if the original mean corresponding to x values was mu, then the new mean, so this is old and this is new set. So the new mean will be a times old mean plus mu b. All you have to do is take the old mean, multiply it with the same number a, then add the fixed number b to it. Similarly, now corresponding to sigma. Sigma or the standard deviation have no effect if you add a fixed number or subtract a fixed number throughout the data, because there will be no change in that dispersion, right? It will remain same. But yes, if you multiply the old data with some number a, yeah, yes, your answer will change by what? A times of sigma. If you multiply the old data set with a number, the new variance standard deviation will be a times old standard deviation. Okay. So now here we have a set of data has mean 12, the standard deviation 10. So old mu is 12 and sigma old is 10. It says each data set is doubled. So originally it was x and we changed it to 2x, then added 4 to it. So A is 2, B is 4. How your mean is going to change? New mean will be 2 times old mean, means 2 times 12 plus 4. That gives me 28. And the standard deviation of new data set. New data set will have the standard deviation 2 times the old, means 20. That's it. So in this way you can find the value for the new data set, right? Either mean or the standard deviation if there is a linear change in the expression. Okay. So that's it for today. I hope you learned all these. Okay. So today we discussed all the points required for this SL 4.3 topic, like calculating the mean, median, and mode of discrete data, as well as the from the frequency distribution table. Also, we have seen all these things. Then finding mid values to calculate the x values for finding the mean. Model class, then interquartile range, calculating the mean and standard deviation, and we also used technology, okay, to find the quartile. We can use directly one variable statistics. If you enter these, for that let me just give you an idea. Later we will discuss in detail. If you enter these in the spreadsheet, okay, and select statistics, then one variable statistics, automatically it give you mean, median, mode, standard deviation, all the quartiles and everything. Okay, so we will discuss all those things in the later sessions. So that's it for today. I hope you got all these. Thank you for watching this. See you in the next part. Keep watching, keep learning, and if you have any doubt or any other question, you can ask me in the comment box.